In this lesson, we will learn that we are wise to align study practices with how the brain works. If we can understand how the cortex and the hippocampus are interacting, it'll shed light on best practices for studying. First, here we see a cross-section through the human brain, and we have a section of cerebral cortex up here. These would be the cell bodies, the neuron cell bodies stained purple, and we can see the cortex kind of folds up like this. So there's a lot of real estate up here, and this would be the long-term memory system of the human brain. Down here we have a cross-section through the hippocampus, so you can see it's a smaller structure. Now, when we study then, of course, we're activating neurons in the cerebral cortex that are processing the information. So we'll get neural activation. The orange neurons are being activated, the blue ones not. And because the cortical neurons send axons down into the hippocampus, we'll get hippocampal activation as well. Now, here's our first study tip. We've got to pay attention. Why is that? Because when we're paying attention, we will have stronger neural activation in those cortical regions that are processing the learning event than if we were not paying attention. The effect of attention is to increase the excitability of neurons that are processing the information. So we'll just get more activity in those neurons, more electrical signals. And since the cortex communicates with the hippocampus, we'll have stronger activation of the hippocampal neurons as well. Now, after the study session then, that's the phase of synapse growth. So if we were paying attention, we're going to have more synapse growth among cortical neurons, forming the memory trace, if we were paying attention than if we were not. And likewise in the hippocampus, more synapse growth with attention than without attention. So the memory traces then are going to be enhanced by attention. We can use our icons here. If we were not paying attention up in the cortex, we'd have a really weak memory trace in the cortex, but since we were paying attention, it's a bit stronger, and likewise in the hippocampus. Now you'll notice the hippocampal memory trace has a lot of ink there. It's seen to be very strong, and that's to reflect the fact that hippocampal neurons have high plasticity, so they're really good at strengthening synapses with one learning episode, better than cortical neurons. So cortical neurons have lower plasticity, so the cortical memory trace is weaker at this time relative to the hippocampal memory trace. Here's another study tip. We want to use deep processing techniques. Over here on the left, the idea is that deep processing study techniques produce more widespread brain activity. So we're using more areas of the cortical surface, more intensely activating those regions, and perhaps for a longer duration as well. All of those factors are going to lead to stronger hippocampal memory traces compared to shallow processing techniques. And remember, we sort of operationally define deep processing as whatever techniques produce a memory advantage, and they do so because they are generating stronger hippocampal memory traces. Now over here, looking at it from the level of neurons, again up there in the cortex, when we're using deep processing, we're going to have more widespread areas of the brain activated, stronger activity of those cortical neurons, and for a longer duration of time. And those features are going to cause an increase in synapse strength. So when we're using the good study strategies, we have the best chance of making the strongest memory traces. Again, using our icons, deep processing tasks lead to stronger memory traces both in the cortex and in the hippocampus. Now we go to sleep, and something very important happens during sleep, and it is memory consolidation. Where the hippocampal memory traces formed during the day's learning, they will be reactivated. That's sometimes called hippocampal replay. It's like we're replaying the day's memories. And so the purpose of this is to communicate with the cortex, those associated cortical memory traces, to strengthen those cortical memory traces. So we call this memory consolidation. We're going to use the strong hippocampal memory traces to reactivate them to strengthen the weak cortical memory traces. And in previous lesson, we used the analogy that the hippocampus is like a printer, printing memories into the long-term memory system. So we're applying more ink. We're going to reactivate the hippocampal memory traces to reactivate the cortical memory traces for the purpose of strengthening them, writing more ink to it, strengthening those synapses. So memory consolidation integrates the day's learning into the long-term memory system. Now, when we consolidate memories in the cortex, of course, we want to keep those memory traces. And by contrast, what we're going to do with the hippocampal memory traces is erase them. So let's take a look at these important phases during sleep. And this, by the way, gets to another important feature or factor in our study techniques. We want to get quality sleep because it's during sleep that we're doing important memory processing. Let's first take a look at how it is that we keep these memory traces in the cortex. So scientists suspect that these cortical neurons, once we grow strong synapses, they stay strong. So there's slow decay of memory traces in the cortex. And this, of course, would be a necessary feature of a long-term memory system. If when we store memories in the cortex, if these synapses just weakened over time, then we wouldn't have a long-term memory system. So once we get these synapses strong, the idea is they stay strong. And that is what makes this a long-term memory system. By contrast, the hippocampal memory traces show fast decay. And we can model this by simply saying that the synapses among those hippocampal memory traces just get weakened. So this is a separate phase of sleep. After consolidation, the brain seems to go through this process where the hippocampal memory traces are erased. The synapses are weakened. Now, why is the brain doing this? The idea is to reset the hippocampus, to prepare it for new learning. So let's think of it this way. In the hippocampus, there are a limited number of neurons, limited number of synapses. So every time we learn something, we're going to strengthen some subset of those synapses. Now, these synapses, therefore, then cannot be strengthened anymore for further learning. So as we learn more and more stuff during the day, the storage space for new memory traces has been reduced. So there's a limit for the memory capacity of the hippocampus because it's a smaller structure, fewer neurons, fewer synapses. So we can't just kind of strengthen all these hippocampal synapses and expect the hippocampus to learn anything more. So again, then during sleep, what we're going to do is to weaken those hippocampal synapses so that they're prepared for new learning. You must be able to strengthen synapses for learning. If all the synapses are already maxed out, we can't learn anything new. So we have a limited capacity hippocampal system, a large capacity cortical system, and that's why we have to refresh the hippocampus every night when we sleep. So we've got to get quality sleep. The hippocampus is a daily learning system. It's doing two really important things during sleep. First, consolidate cortical memories. We do hippocampal replay. We fire up those strong hippocampal memory traces to strengthen the cortical memory traces, and then we weaken those very same memory traces to refresh the hippocampus in preparation for new learning. So let's pause here and review again why it is that we go through this memory consolidation process during sleep. Let's take a look at the numbers. Approximately 50 million neurons in the hippocampus, 16 billion neurons in the cortex. So we've got more neurons and synapses in the cortex, more storage capacity. So again, the cortex is a larger memory capacity system, and the hippocampus a small memory capacity system, limited number of neurons and synapses. So this is why then we're going to have to be doing consolidation to take these hippocampal memory traces and use them during sleep to strengthen the cortical memory traces and then refresh the hippocampus for new learning. So we better do this consolidation, get the memories stored well in the cortex, because we've got to weaken the memory traces in the hippocampus. So this also leads to a study tip. We want to study again when the hippocampus is refreshed after sleep. So we already had one study session, now we went to sleep, and now we wake up the next day and our hippocampus is nice and refreshed, ready for a second study session. And that gets us to this other tip, why it is that we have to repeat our study sessions. This is a really important thing to do if you want to get educated. Well, what's going to happen when we sit down for a second study session? We're going to be activating those same cortical memory traces that represents the learning from the first study session, but we still had relatively weak memory traces because we only studied once, only went to sleep once, but we're going to reactivate them and make a fresh hippocampal memory trace that second study session. Now, why is it, though, that we have to repeat our study sessions? And here, this picture illustrates the concept that scientists think that the cortical neurons have low plasticity, which means they need repeated activations to strengthen those synapses. By contrast, the hippocampus has high plasticity neurons. We saw earlier that one learning event can trigger strong synapse growth here. So we would say the cortex is a slow learning system because of the low plasticity neurons, whereas the hippocampus is a fast learning system, high plasticity neurons. So we've got to repeat our study sessions because the cortex is a slow learner. So we want to have 1 study session, 2 study sessions, 3, 4, and we want to separate those study sessions with sleep. Over here on this brain here, we can see why. So every time we study with sleep in between, we make a fresh hippocampal memory trace that can be used during the night's sleep for memory consolidation. So each time we do memory consolidation, we're strengthening the very same cortical memory traces. So the effect of repeating our study sessions is to give the brain the chance to really strengthen these cortical memory traces, strengthen those synapses. And we saw earlier, once you get them strong, there is slow decay. Now, we also, the flip side of this is we want to avoid cramming. Cramming, by definition, we just study once before the assessment. Cramming produces only small gains in synapse strength, again, because of the low plasticity neurons, which means we'll be left with weak memory traces, and that'll lead to fast forgetting. Now, we said the hippocampus is a fast learner by day to be a kind of teacher at night when we go to sleep and we do memory consolidation. But this feature of fast learning, high plasticity hippocampal neurons, that also leads to a limitation in our study practices. We want to use short study sessions. Now, why is that? Over here, we see some cortical neurons being activated, and they're communicating with the hippocampus. We got some hippocampal neurons making a memory trace down here. Continuing a long study session activates the same hippocampal memory traces. Now, this is a problem because we said those hippocampal neurons had high plasticity. We're going to reach a plasticity limit here. So we'll get synapse saturation, and that's going to occur early in the study session. So because these are high plasticity neurons, the first 20, 30, 40 minutes of our study session, we've already strengthened these synapses to their maximum level. If we add another hour or 2 hours studying the same information, we're not going to get any gain in synapse strength here. So how is it that we can get around this problem? How can we get different hippocampal neurons to make memory traces for the same information we want to study? And the trick here is to take a break. Breaks make it more likely that different hippocampal neurons are recruited to form a separate memory trace. Those fresher hippocampal neurons have synapses that are more capable of new growth to represent the learning in the second study session. So if we take a break and study again, then we'll have 2 hippocampal memory traces that are connected to the very same cortical memory traces. So when we go to sleep, both of these hippocampal memory traces can be replayed, and we'll get even a larger effect in strengthening the cortical memory traces during memory consolidation. And finally, what about retrieval practice? Well, when we retrieve information, our memory search systems are trying to locate and reactivate stored memory traces, the desired information we want to retrieve. Well, retrieval practice is the very kind of study technique that will help us strengthen those retrieval pathways. So it's not enough to have strong cortical memory traces. We have to have search systems in our brain that can find those memory traces. And retrieval practice helps our brain keep those retrieval pathways strong so that we can quickly find the memory traces that we desire to reactivate. In a previous lesson, we used this diagram to illustrate one important kind of forgetting as loss of access. On the left, we have some strong cortical memory traces and some strong retrieval pathways. This person can quickly and reliably reactivate the stored information. But if they don't retrieve that information for a long period of time, we call that disuse, then what can happen is that while the cortical memory traces are still there and strong, our search system can lose access to it. It can't find those memory traces. And the effect is that we will fail to retrieve the information. We will have forgotten. But the memory traces are there, but the search system can't locate them. So retrieval practice prevents this very important form of forgetting. Every time we retrieve, we're strengthening those retrieval pathways so that our searching system, our cortical retrieval system, can find those memory traces. But that's not all. Retrieval practice also does something else that's valuable. Every time we reactivate a memory trace, we give the brain an opportunity to make a new hippocampal memory trace. right? Every time cortical areas are activated, they communicate with the hippocampus. So when we retrieve a memory, it's like a new learning event. We're going to make a new hippocampal memory trace. And then during that night's sleep, we'll go through memory consolidation again, using that new hippocampal memory trace to strengthen the very memory trace that we retrieved earlier that day. So we can make cortical memory traces even stronger every time we retrieve a memory. On the left, here's a situation where, let's say we studied once and then we went to sleep. We still can forget what we studied the night before because with just one study session, we have relatively weak cortical memory traces. And again, we've refreshed our hippocampus. So we might forget because these memory traces are weak. And this is another form of forgetting as storage failure. That with only weak cortical memory traces, that can lead to fast forgetting. So when we do retrieval practice and we set up another round of consolidation during sleep, we are strengthening the cortical memory traces. And that leads to a situation where the cortical retrieval systems will have an easier time finding and reactivating those memory traces. So again, retrieval practice directly prevents another form of forgetting, the storage failure. We've reached the time to sum it all up. We want to be paying attention. Why pay attention? Because that increases the neural activation of the cortical regions processing the learning event, and the effect of that will make stronger memory traces in the cortex and in the hippocampus. We want to use deep processing, again, because that'll make stronger hippocampal memory traces. We want to get quality sleep because we're doing memory consolidation. We're strengthening the cortical memory traces using the strong hippocampal memory traces formed during the day. We want to space out our study sessions with sleep in between because then we'll have a refreshed hippocampus, and we need a refreshed hippocampus to learn anything new. Remember, during sleep, the second stage of sleep, we are weakening the hippocampal memory traces to prepare for new learning. And why do we have to repeat study sessions? Because the cortical neurons have low plasticity. So we have to repeatedly activate them to strengthen those synapses. But once we get them strong, they will stick around. We want to avoid cramming because then we'll be left with relatively weak cortical memory traces and fast forgetting. We want to do short study sessions with breaks, because that makes it more likely that some fresh hippocampal neurons will be recruited to make this memory trace for the second study session. In general, we want to study when the hippocampus is prepared to learn, either after sleep or after a break. And finally, retrieval practice does two really good things. It strengthens the retrieval pathways, and it gives the brain another chance to do memory consolidation, thus strengthening the cortical memory traces of the information we were retrieving during our study session. In addition, retrieval practice can help us with our metacognition, and it tells us what we know and we don't know. So the point of this lesson then was that if we understand the dynamic interaction between the hippocampus and the cerebral cortex, it sheds light on the best practices for studying. We've got to align our study practices with how the brain works.